Всем привет.
Hi there. My name is Alexey and I'm going to talk to you today about SCA challenges, what it is, and what are the challenges, and how it all works. I'm here to present Profoscope, and we do automated audits, and we develop automated audits, and now we have a system for compositional analysis that is called code scoring. It's been a while since we started analyzing source codes, and we have our own conference for source codes and open data science community. We also make free of charge open courses about, in particular, about licensing of open source software, which is also relevant to SCA, but it's not the topic of my today's presentation. And we're always happy to raise the awareness in these matters. Just to give you some context and some numbers, you all know the numbers that we have a lot of open source code out there, more than 200 million unique projects, as they say. It does not necessarily add value because the valuable projects are less than 200 million, but at least one commit was done by around 70 million people, and the number of people doing open source commits is going up, and the usability has gone up by 72% in 2020-2021. We also know that the numbers of supply chain attacks increases. We are not going deep into the topic of supply chain attacks in this presentation, but we bear this in mind, and this growth in the number of supply chain attacks is something that can't but bother you. And these are the data on packages growing in package indexes, the new versions emerging in the market, and in the year 2021 alone, at least 1/3 of new packages arrived. Cool, right? And also so very many new versions, and you have to follow all of them. You have to update information on them. You have to identify the necessary resolve the necessary issues, find vulnerabilities for all these new components, identify licenses, build compliance, etc. And here we don't even have space for JavaScript in this slide. The number of components in JavaScript is growing, and quite significantly. Those who really know everything about DevOps, and they know how to release 10 times a day. Python, very similar to Java, slightly less pronounced though. And we can see around 300,000 packages in Python. And we can see that in the year 2021, we have around 1/3 of new projects arrived. So it all gets released, the new versions appear in the market. Open source is popular, and this popularity obviously spurs the industry, the development industry, and development becomes faster. And also, it's worth mentioning that open source contribution to the code base is larger and more substantial. I'm not insisting, but as a rule, open source is the majority. According to TideLift, 92% of your codes, 92% of proprietary projects make use of open source code, which is a big number. So this is how we come up with this pyramid, with open source in the basis of this pyramid, like a platform, really, a foundation, I would call it, and we have closed code on top of it. The closed code is the unknown. It's something that needs to be researched in order to find something or anything interested in it. And obviously, it could be open or closed to different extents. And there is also open source code, which is known, which is scannable, and a lot of researchers dig into it and publish correspondent information on the kind of vulnerabilities there are and how they got fixed. And it's popular not just among the developers, but also among the researchers. It's pretty obvious that you really want to account for the index of package used in the community and in the code base. And we can see the popularity of packages, if you just take top 10, is more researched, and in 36% of projects we can find vulnerabilities. And it's interesting to follow these vulnerabilities, it's interesting to follow this progress. In the rest of the package base, only 8% contain vulnerability. And popular packages are the ones better studied, right? And you know the vulnerabilities there. And people don't shy away from demonstrating and actually making public the exploits that can be, well, exploitable. Speaking of the growing open source, we would say that number of vulnerabilities discovered year on year is growing as well. If you look at the number of vulnerabilities, well, open source vulnerabilities grows in 2021, it actually breaks through the roof. But at the same time, if you look at separate feeds, separate packages, and analyze GitHub Security Advisory, these columns shows that discovery is not even. It does depend on the feed holder focus, the ones who process it. If we look at Maven, for example, in 2020 it was very high. In NPM, they started to do something about vulnerabilities around, 2-3 years ago. The black are the critical ones, as you can understand. And then PIP was of great interest in 2021. In 22, it's also of interest, but not yet. We don't yet have too many vulnerabilities identified. And open source, much as we love it, is not secure. Yes, we love it. Yes, we make use of it. Everybody loves it. Everybody makes use of it. But you have to check it for vulnerabilities. Everybody knows that it contains vulnerabilities, and you have to do something about it. You either scan it, the whole of it, or read. Some other people read the code. Within the framework of SecDev, there is this whole concept of handling the licenses, because licenses may be incompatible or non-existent, and there are all kinds of risks like export limitations that may impact licenses that are not exactly approved, self-approved, for example, licenses. And backdoors is a separate thing. They could be embedded into any kind of software, and it can be triggered by various things, and they are detectable, they are being studied, and by stat analysis in particular. And backdoors, when identified, also get their correspondent code of vulnerabilities and are published. So de facto, they're also vulnerabilities. So in order to work with that, not just with the vulnerabilities, backdoors, and licenses, you would use software composition analysis. And let me give you some background information about it, just in case you don't really know what it is all about. So SCA is about studying components of a software. and identifying these components. So you basically disintegrate the packages, and you come up with the list of packages with all the material information contained, and representing this information with all its risks to the user so that the user can take action. More often than not, it's pretty straightforward, and it consists of three steps. First one is inventorization. When we scan our code base and we identify the dependencies, we identify where we have directive or direct dependencies, where we have transitive dependencies, dependencies of dependencies, all these trees. And then all these things we identify are checked against a vendor base, open base, then we detect it, and we identify the licenses, we identify all the vulnerabilities that are there in the database, and so we take it and stay informed and formulate our policies and take actions. Speaking of actions, this may start with like a notification. You get a dashboard, a notification, or a Jira notification, or even blockage. But it all begins with inventorization. I think you would agree. So in order to carry out this inventorization, you don't have to go to a warehouse and count your software manually. There is a possibility for using automation. And it consists of three steps. First, you study the manifests. So basically, it's static parsing, static analysis, which consists in parsing of the correspondent notations in the manifest that tells us of which packages are used, which versions are used. It not that it comes without a problem. I guess many of you have encountered with data science, and I love this example of data scientists in this context. In dependencies, data scientists would only give you the title of the package, and that's it. And that's all very understandable. It's not their responsibility. But anyway, dependencies can be there. They can be with or without taking the transitive dependencies into account. And it all depends on whether you build a log files, gradle log, pointer log, or anything. Do you build your transitive dependencies on your own? It's basically your development culture. If you don't do it, then SCA, a compositional system, it wouldn't find transitive dependencies, and it would try to build it on its own using the environment and using its own discretion. So these are the two basic things that that you have in SAST scanners. And there is an additional functionality, identification of open source inclusion. You all know Shazam application, right? When you listen to a piece of music and you manage to get information on everything from the title of the album to all the way to the right. Well, you're not very interesting in the rights, but anyway. Same with the code. SCA, we listen to the software, we get information on hashes, and those can be crypto resistant or non-crypto resistant, and you have a Shazam of code, and you have an open source inclusion identification. Open source inclusion is when you take an external library and then put it right there in your code base and make use of it because it's fast, it's straightforward, and you may find it alarmingly wild, but this is something that happens and happens all the time. And the problem is that in this with this open source inclusions, well, they are included and they lie there idly or not idly, they're being used, while the sources and your own source code starts to get entangled with those inclusions. And these inclusions, they get updated, they get new functions, they contain vulnerabilities. Oftentimes, say, you get this inclusion and it works and everything is fine. And it's there for 10 years and we have a lot of vulnerabilities there. And it happens. I mean, it happens quite regularly. So after you study the manifest, the transitive dependencies, not just parsing of files, but resolving the transitive dependencies and identifying the open source inclusions, you get the so-called software bill of materials, or SBOM, software bill of materials. So it contains all information on all dependencies and control sums. It can be enriched according to particular standards with information on vulnerabilities, on licenses, all that. It may contain a lot of data. Then how SCA system is used. It's either done in the mode of firewalling components. We want to prohibit things, and we want to prohibit at our own discretion. We have this open source with all the components that flies in and it gets stored, and we make use of it. And on the other hand, we have the users who want to get something new at all times. And this is an issue, and we need to follow it, and we need to understand what they do and how they do it and when they do it. Then CI/CD security gates is another option. When for each build we look at and we analyze and we identify what's wrong. And also there is this mode of continuous monitoring. You know that you have already released. If you are related to software development, you know that you released, the version is out, people keep using it, and old versions are also still out there, and you need to know how vulnerable they are. Same goes to premise products and all that. Everybody tries to update regularly, but the issue with vulnerability of the previous versions of your software does exist, and you need to follow it. The so-called shift-left approach is oftentimes mentioned by partners rather than vendors, but this is indeed very relevant, and not just it does not only concern the old versions. You also want to monitor the code that you get here and now, out of dev fingers. And you can actually monitor even some branches when we develop separate things. There is this whole other thing of integration into IDE. And according to our polls, looks like this functionality is just seen as convenient, but it's only convenient for those who know what they want and how they want it. For the rest of people out there, IDE function is not being used. And this is something that needs to be changed because everything comes out of minds and fingers of our developers. So how it works? This is SCA firewall. When you have open source on one hand with all kinds of NPMs and Mavens and Python and all that, and we do understand that one thing is to put a link to GitHub, and the other thing, when you have Maven Central Hub, there are more than 200 of these indexes, and you need to gather this information and provide it to the users, and you need to deduplify it and find gaps and remediate typos and work with this information. So when you look at your component base and you monitor your component base, you begin by creating a warehouse of artifacts. There are various types of solutions you can use here. You can use GitLab or anything else. Some of it is on the slide. Then you have either a plugin with SCA or you use some program interfaces, and you get information on whether or not this goes through the quality gates or security gates that is identified in your SCA policy. And after that, it's either quarantined or goes on for development. If it goes on quarantine, you get notification and you keep working, you keep checking the package. For example, if it's launched after a particular date, you put it on test analysis or you try to understand what goes on with it. Same mode, the second mode is SCA used for CI/CD. So what we have is GitLab, TeamCity, Jenkins on the one hand, on one side, and SCA system that checks our policies. And what it does, it fills our software bill of materials, and we can play with it, and it forms particular logs that you can look at, and importantly, it also blocks build. So if we see something and we didn't have a firewall, we can catch it before it goes to the build phase. And SCA continuous monitoring is when you obviously continuously look at vulnerabilities emerging, and we understand that the older things are more vulnerable. Well, vulnerability doesn't really change in time if packages do not get changed, but vulnerabilities tend to get identified, publicly identified, and if they're public, then they are scannable and exploitable. Policies differ. In this case, we are talking about SCA policies. So it's if TTT, if this then that. You may find a critical vulnerability that is not good enough. You get a package in the top list, or you have problem with the license. SCA is something that does it. It's just part of security development. If you make use of component that is not legitimate to be used, then at some point of time, someone would come to you and say, that's not acceptable. Not necessarily your legal specialist. And at some point of time, you have so many things attached to this non-legitimate part that it's very difficult to take it out. So what you need to pay attention to when working with SCA, identifying vulnerabilities would be the first one. You need to understand what are the databases used, what are the feeds used to get information on vulnerabilities, because this is the most important field. It's very important to understand how deep the database is, and I'm going to discuss it. And we find vulnerabilities in two public hubs, in CVA database and GHCA, and also some commercial databases. It's being updated. Analysts work with it. Well, not necessarily in a good way. And sometimes it's rather difficult to make use of it. You really need to correct the databases and do it iteratively. In order to, and then I address this to vendors, in order to work with these databases, you have to make use of various identifiers. With more than 50 versions of packages and the vendor names changed and names of packages changed, you really need to understand how to go about it. So in order to identify the package, you may have several practices. Common platform enumeration, the so-called CP, and package URL, or PURL. The second one is less used, but not yet deeply implemented. So CPE is a special identifier that allows you to come up with a special vector that would tell you everything about what kind of software it is. It also describes some hardware issues. And vulnerability match is done using CPE dictionary, and I'm going to have a separate slide on it. So you see the vector, but it's kind of not native. We also have package URL or Perl. A lot of developers, SCA system developers, take it seriously. It's more native and it's readable. It has the attributes, it doesn't have the hardware. And there is a identification problem. If you use it in CPE mode, there is a human factor that may be a problem. The problem with CPE dictionary is that dictionary are not are sometimes not really full. People make mistakes. People make typos. Sometimes the programming language is not mentioned, or some other important attributes are not mentioned, or vendor name may have changed, product name may have changed. Open source as it is, right? Everything keeps changing at all times. And obviously, you can do something about it, but it's still important to do something, and you have to make use of particular algorithms of natural language processing, doing a very minimum machine learning to find and test correspondent aspects. And it all gets added by manual rule-based search. It's a necessity. Another problem that I would like to talk to you about is transitivity of dependencies. Okay, we have 5 components or 10 components, and it's okay, we can check it manually. Well, cool, but these components are dependent, and these dependencies can mutually impact each other. Do you know about log4shell? Okay, you have. Great. How about search in your component days? Right, you searched for it. So this is a well-known topic, and those of you who search for this kind of vulnerabilities would confirm me in saying that it's not always that you can directly find it through direct dependencies. So let's do problem setting first. It's pretty easy. We have this well-known group of vulnerabilities that we started to identify on the 10th of December 2021, and we started to remediate it. It was a very unpleasant thing, and it was all over the news. So a lot of DevSecOps, a lot of developers, they started to search for these kind of vulnerabilities. All the way till it got remediated. And actually, they thought whether to go further or to get back to the previous version of 10 years ago. So here you see a Google security graphic representation as of December 2021. After the first vulnerability was identified, we have all Maven packages in Maven Central Artifacts, and we have the numbers that are vulnerable. And in the first 6 days, around 10,000 were fixed. And I think it's a nice rate for open source, everybody going ahead and trying to fix it, and I'm going to explain why it's cool. But then there are 30,000 packages that haven't been remediated. 6 days, everybody's shouting out. It was like almost like a pandemic. Everybody were going ahead and searching for it. Probably I am exaggerating a bit. So why it's not that simple to remediate log4shell problem? Because it's deeper. If you use log4j directively and you work with direct dependencies, but if it comes to you through transitive dependencies, it's very difficult. It's much more difficult. In this picture, you already have certain transitive dependencies. If you have direct dependencies, then you remediate it and that's it. But you also may have transitive dependencies. Who is going to remediate that? We remediated the vulnerability identified, but how about the maintainer of your transit dependency source? How to go about that? Shall you do it manually and then update if you find it important? Or shall you maintain it in any way? You need to do it. And it takes time. It takes a lot of time. And speaking of depth of penetration, same graph. I think it's rather interesting. If you look at those 40,000 packages that had in it log4shell issue, not log4j, log4shell, you would see that in terms of direct dependencies, we only have, around 15% of them. Only 15% were with direct, while the peak of vulnerabilities is in the 6th level of dependencies. If you analyze all log4shells, we see that it's a big tree, a branchy tree, and you need to be knowledgeable about the fact that you have a branchy trees and you have them nested in one another. And you necessarily have to use automation. If you're a data scientist or researcher and you have 3 dependencies, then yes, you can just put the last versions and do that. But it's not really a good approach. You really want to use right package managers and manage security information around you. I could see you were nodding your heads when I said that 10,000 packages in 6 days is fast. Well, indeed, it is fast. And this is something that is changing considerably in the market. 8 years ago, an update, time to respond to a vulnerability would be slightly more than 12 months. And that was when we already had DevOps that allows us to make thousands of releases per day. And DevSecOps, Manifesto, and all that since the year 2012. We all know that it's cool and great, but in 2014, as of 2014, it takes around 300 days to respond and remediate a vulnerability. In 2018, it's 158 days, and in the year 2021, it's 30 days. And it's fast. 30 days is already fast. If you do it, if you're specialized on that, you can do it even faster, or at least they think they can do it faster. Well, anyway, in order to do it fast and effective and efficient, you really need to make use of automation. So next thing I want to mention in this context, speaking of trends and challenges. Well, I'm talking to you about all kinds of problems like dictionaries that lack some data. But, well, SAST is another issue. To know the known is not enough. To know the known vulnerability and work with them is not enough. We scan it and we find all the packages with all the known vulnerabilities. We don't have any empty data. We found all the vulnerabilities, remediated it. Everything is cool. But it doesn't work this way, does it? I think you all understand that. That's why there is this motto, SAST, DAST, and SCA. It has to work as a group, and it works depending on tasks. But again, SCA system looks through open source components and identifies the vulnerabilities, but SCA wouldn't analyze the code, right? As a root list. The trend today is that major vendors now try to add SAST on top of the SCA. White source, Sonatype, all of them are trying to do something about it. But the reverse is true as well. I want to draw attention to the fact that if you scan all of your open source, which is a big chunk of your database, who's going to go ahead and analyze it? In the year 2021, they took all the piping and they put SAST on top of it. And 50% of packages are vulnerable. If you now look deeper or you read the article, you'll see that there are vulnerabilities that are rather, sizable, substantial, like injections and all that. And you want to do something about it, right? You want to work with it, and you can't work with it just by SAST without component-based analysis, without SCA. You may believe that SAST is really cool, but we do understand that open source project code we have so much of this open source code that you have to do something about it, and you can't go with SAST. So SCA adds SAST, and SAST start to work in SCA mode. So they kind of try to integrate and probably even mutually displace each other at one point. Another aspect that now leaps to the eye while we've been thinking about it for 10 years, I would say it's karma. When I was getting ready for this presentation, I thought of telling you a few words about what happened lately, that in the last 2 years we have a lot of deletion of packages from package indexes just because the developer wanted to do it. And I'm going to tell you about it, but 1 year ago I was making a presentation on SCA. And I was told that, yeah, it's all right, but open source is such a good thing, it can't be vulnerable, it's all in your head. All the vulnerabilities are in your head. Yes, I laughed at them. Really, out loud. I mean, you are deep into the process, and you know how it works and how it is being studied, and you understand that, no, this is the code and it's vulnerable. Go ahead and try to do something about it. Right? Well, I explained myself. I was very nice in doing it. But the person who was posing the question didn't agree with me. Time has passed, and I think I now understand this guy. And yes, you can be very verbose about it. Developers may be different. The developers started to misbehave, deleting versions of packages while the packages are very actively used. And it's an issue. And package index owners are not just like Microsoft, but NPM and PyP and others. And people's attitudes differ. Let me give you some food for thought. We let's say we had Google Play and App Store. What happened to these apps? They're being checked, and sometimes they're checked for security. In open source, and again, it's just by way of analogy. Can you imagine in open source someone to find resource and stamina to check all the packages that come into the open source? I think it would just freeze the build. Well, probably people would start to actually look for vulnerabilities and the market would grow and it would be a positive thing. But again, if you limit the packages coming, it's not going to work to the benefit of the community because open source is open and this is the way you have to work with it. And yes, you can take measures, say a popular packet cannot be deleted, or if it is deleted, then it has to give some certain time for people to cache something if they want to. So this is one thing. And this is related to the security and to the your mental image of vulnerabilities. Sometimes people introduce malware and they kind of turn the arms on open source community and create vulnerabilities, and it's a fact, and everybody knows that, and it exists. If we're talking about injecting malware, it gets vulnerability code and it's identifiable. It's identifiable by SCA or sometimes even by SAST if you wish to read all the updates of all the new versions, which is quite a task. You also need to follow popularity of authors and how it all works. And if the person has compromised his reputation, should check whether he is still in the community, or probably a similar package arrived from a site. So you need to follow it. And this is an aspect that is not related to a code analysis. It's SNL. You need to analyze authors, you need to analyze package popularity, and SCAs today, they analyze package popularity to underscore the vulnerabilities that might be of interest to you. In conclusion, I'd like to say that SCA is a foundation and a way and a preventive means. And it's not final, by all means. We know that after SCA, not all vulnerabilities are found, and you really want to get integrated with the neighboring systems. And it's a task for SCA and SAST alike. But anyhow, SCA is a way to control the situation, and you get automation that is rather straightforward, and you understand what to do next. Yesterday, I had a great presentation on security champions, and I remember a question from the audience, where to start. It really depends on the security champion person you picked. But SCA is an interesting and straightforward thing. You just use it, And this is a very interesting way to start with. If you're a newcomer to security, this is where you start. This is how you start to understand that, okay, this is software, and you get the links to exploits, and then you get smarter and you go deeper and work with those deeper areas. It all may be fun, and you probably expected me, as a representative of SCA provider, to say something like that. SCA needs to evolutionize. We still have issues, and we know of the issues, like ranking, like false positives, like dictionaries, dependency dictionaries, component identification, looking vulnerabilities. SCA has to be more proactive and more integrated with SAST and identify vulnerabilities in new packages before it arrives to SAST. Because before you arrive to SAST, you already start to make use of this package, right? And you also need to bear in mind that some of the vulnerabilities are only there in your head. We still want open source, and we still want to stay secure, so let's do that, bearing all these aspects in mind. Thank you. Thank you very much. I believe that the earlier you find an issue, a security issue in particular, the cheaper it is to remediate it. Say in modern versions of programming language compilators, their warnings and errors they get more and more to the beginning, and people understand that you need to remediate it, even at the stage of studying or learning programming languages. But it's not there in programming managers. There are some plugins in Maven, but they are external. They're not embedded. I don't have any. I can't think of any that comes out of the box. Why is that? Is it done on purpose? Or probably we are going to have package managers that would, by default, when being installed, carry out this basic, well, at least basic comparison against CVEs. You know, just to notify, to get no warning. You write the input. Why not notify him there and now? Why it's not there now? Well, I think people are afraid. They're afraid to expand too much of resource and to send domino effect across the community. These data are not clean. And NPM, let's take NPM for example. You really have to have resource to do something about it. If you moderate all of open source, I think it would take, it would take more effort than App Store. And you can introduce simple scanners. Say, should we have a package index, we would do it. So my answer is because people don't want to expend too much resources. And despite the increase in popularity, you really have to live with what's there. Thank you. Thank you for this presentation. My question is about check marks. Check marks is a new type of solution which analyzes if commits are there in GitHub, and then you look at the npm package, and if there is a supply chain attack and new version of npm package is there without the correspondent source code, these packages are taken away. Do you plan anything like that? Yes, by all means. And this is how it's done. Currently, we're working on it. It may seem to you that I'm right from Gartner. In our laboratory, we have a lot of things going on, and we are planning to launch it into the market when we are going to apply more of a cloud approach than premise approach, on-premise approach. Another question also related to checkworks. They have an interesting feature. SAST identifies in the library the code that is not being used, and if the vulnerability is in the unused code, then it's alerted but not remediated. Are you planning any integration? Yeah, 2, 3 years ago, we were telling you how it's being done in our presentations, but you know what? Log4j is used, but there is this open source code that you are not used, but vulnerability is still there. And I think it's a big issue. Entering, into the SAST field, I cannot guarantee that I do not create false positive. What if, yes, the code is not used, but vulnerability is still relevant because of architecture? I don't see the point, and I don't know how checkmarks can remediate this issue. And sometimes they would say that this is used and this creates false positive. Yeah, thank you. And one more question. Yes, please. Thank you for this presentation. Very, very interesting. To add on to what that gentleman said, that it's very resource intensive to cover with SAST. Anaconda has its own package manager and tries to moderate packages, but they have less packages compared to PyP. Indeed, Anaconda are great. There is a commercial company behind them, and it's a specialized area. It's for science rather than for everyone, I think. This is what Anaconda does. And people who work there, they don't think of security. Right. Okay, but the problem is there. And those who work with Anaconda, they are very happy about it. And just, I also want to tell you, I scan PyP and I identify malware and I report this malware and the backdoors and I report on it and I get feedback. But my question is this. If I have a one-day account that was created for the sole purpose of using like squatting, right? Yes. And in the very beginning and the very end, you mentioned karma and compromising the developers who do bad things. Are there any systems and communities where you can address and tell that, look, this package over there, this developer did wrong, and to create a database? There is no public database of quote-unquote bad developers. You can just report it and that's it, unfortunately, at this point. No international communities like that at this point. We're open for dialogue, though, because we're very much, we think that it's an important thing. Oh, I'm sorry, out of time. Sorry about that. Thank you for your attention. Thank you for your questions.